Alright, we're going to shift gears here slightly and focus on simplifying expressions by combining like terms. This is in the notes on pages 5 through 7. The previous examples we've done with the order of operations, that's primarily arithmetic, and you get sort of bogged down in that process of having to simplify very carefully and do a lot of number crunching. These problems aren't going to be like that. What you're going to see here, though, is that the variables, the letters, stick around through the whole problem. So it makes the process feel a little more abstract, and for some students that can be a little bit of a challenge at first. But I think you'll actually find these type of problems a bit easier than the ones we've been working before because there's less number crunching involved. Now the phrasing combining like terms, that's referring to addition and subtraction. So when it says simplify expressions by combining like terms, we're talking about adding and subtracting and combining expressions together. In order to do that, those terms have to be like terms. So let's take a moment to look at what it means to have like terms versus unlike terms. You've probably heard of that expression before. You can add apples to apples, but you can't add apples to oranges. That's pretty much what we're talking about here, in a sense. Let's take a quick look at that idea. So let's take a couple of like terms that we can add together. Something like 3x and 2x. 3x plus 2x. That would be like saying 3 apples and 2 apples. I can add that, get 5 apples. So 3x and 2x is 5x. Not hard to do. Now, how do you foul that up so you can't combine them? How do you make it so you've got apples and oranges? Not too hard to do. One way to do it would be to change the letters involved. So say 3x and 2y. Now you can't combine, because how would I write the answer? How would I combine these? 3 apples and 2 oranges? That's not going to work, is it? What are you going to say, 5 pieces of fruit? Well, that works well in English, but you can't do that mathematically. So these can't be combined because they're not like terms. They have to both be x's in order to work. Also, the exponents have to match. So let's go back to our like term scenario. Suppose we had 3x squared and 2x squared. All right, that'll still work because that's like saying, I don't know, 3 pineapples and 2 pineapples. Yeah, you got 5 pineapples on your hand. No problem. But if one of these has, say, the square on it and one doesn't, so 3x squared and 2x, then again, this is like apples and oranges. How would I combine those? 5 what? If I say 5x squared, that ignores the second piece. If I say 5x, that ignores the first piece. You can't win here. You can't combine these. So you have to have the same letters raised to the same exponents in order for them to be like terms. Now that's not too hard of a game to play. It's just that's the way the game is played, so pay attention to both the variables involved as well as the exponents on them. Alright, so let's go ahead and take a look at our first example here. This will be a very easy one to start with. And then we'll move to another one that's a little more involved, and we'll bring in the distributive property. I won't write the distributive property down right now because we don't need it yet, but I'll bring it in when we need it, because that's one of the primary tools that we use on these problems. So we'll get to it here soon enough. But I want to start with a very easy example just to emphasize the game that we're playing here. So that very first example on page 5 is not too complicated. So here it is. We got 5x squared minus 4x plus 6x plus 11x squared. There we go. Alright, so all we're trying to do is hunt down the apples, add them together, hunt down the oranges, add them together. Not difficult to do. If I want to play the game with colors, let's say the x squareds are apples. So there's some apples. Here's some more apples. There's all my apples. I'll add those guys together. And then what about the oranges? Well, here's some oranges here. There we go. And there's some more oranges. All right, so I'm just highlighting the like terms. And all I got to do then is combine like terms, add them together. So if I have 5 apples and 11 apples, that's going to give me, what, 16 apples, or 16x squared. Negative 4 oranges and 6 oranges, that would be 2 oranges altogether. And there we are. Not too challenging of a problem. But I guess it's a good place to start, simply because it shows you this is the game that we're playing. It's a pretty simple game. Like I said, these problems, by and large, are going to be a lot easier than those order of operation problems. Not nearly as tricky with the computations and number crunching. All right, let's do another problem. It's a little more involved than this. And let's bring in our distributive property to help us out, because we'll need that for this next one. Okay. So here's our next one here. Looks like this. Next page over. Skipping down to the third example here. 8 times 3m minus 2. And we're going to subtract off 5 times 4m minus 5. Alright, so once you start seeing the parentheses in the expression you're supposed to simplify, that typically means you're going to need to use the order of operations, because the purpose for us for the order of operations is to get rid of those parentheses. That's what it does. So let me write out the distributive property over here. Distributive property. And show you, or just remind you, you've probably seen this before, many times before. Basically, the way you usually see it written is you have some number, we'll call it A, outside the parentheses, and then something inside the parentheses like B plus C. And the idea then is to get rid of the parentheses, you distribute that A through. You distribute the multiplication through the addition. Looks something like this. And it distributes to both the A, or sorry, distributes both the B and the C there. What does that give you in the end? AB plus AC. And it works the same way if you had subtraction as well. It doesn't really matter whether you have addition or subtraction. You'll get AB minus AC. In fact, you could even have the A on the right side distribute from the right if you want to, although that's a little unusual. You could do it that way. Okay, so let's apply this to our example here. So on this first chunk right there, we're going to take that 8 and distribute through. Not too hard to do. What's it going to look like? Well, you're going to have 8 times 3m is 24m. Then what? Minus, there's a minus sign there. 8 times 2 is 16. So there's your first part. Now you got to move on to the second piece to get rid of the parentheses there. Watch your step, of course. As you probably remember, it's a package deal here. Wherever that 5 goes, that negative sign is going to tag along with it. So the entire -5 distributes. So make sure you distribute your negative sign along with the 5 itself. If you forget to do that, it's going to foul it up. So what do we have here? We got -5 times 4m is a -20m. And the -5 times -5 is a plus 25. Now we're on easy street, because all I got to do now is add the like terms. That's easy to do. I got 24m and a minus 20m. That gives you 4m. And a -16 and 25, add those together, you get a 9, and there you are. Voila. Not too bad. So the moral of the story here is distributive property is the tool that gets rid of parentheses. You take care of that right away at the beginning. Once the parentheses are gone, then you proceed to add like terms as always. All right, not too bad. Let's go ahead and get rid of this and take a look at some others. There's one or two others I want to show you here. If you come across a problem with decimals in it, problem 5, example 5 on page 7 has some decimals. Just use your calculator. In fact, I won't bother doing that here because you know how to use a calculator, I think. And by all means, you want to have it calculated for the course to help you do some of the homework problems and the test questions. You can use a calculator on the test, that's fine. Let me kind of get this situated correctly here. Every time I erase that board, this gets all tilted. Whack. All right, so let's get to a challenging problem here. Number 6 is, I think, one we definitely want to work through together. This is going to take a little more effort because it's got fractions in it. And if you don't care too much for fractions, if they're not your friends, if you flat out hate them, well, I'd just say join the club. Nobody tends to like fractions a whole lot. Why? Well, because they tend to be difficult to work with, right? You know, adding whole numbers together is a piece of cake. Adding fractions together when the denominators are different, that's a lot harder to do, and that's why people tend not to like it. But you got to be able to work with them because they're everywhere. And you'll see them in the homework. You'll see them on the test, so you have to learn to deal with them. And so let's go ahead and march through this problem here. It'll be a little more challenging, but again, if we take our time with it, we should be able to manage it all right. Now, like the previous example, we're going to use the distributive property to get rid of the parentheses. Because we got a bunch of parentheses in there, we need to get rid of those right at the beginning. So let's take this 4/3 through here, distribute through. There it is, there it is. Not too hard to do that. But if you're having any trouble with this, let me take it off to the side here to make sure you can do that calculation without too much trouble. So I'm going to take this 4/3 times 2x down here so you can see it. So if I multiply by 2x like this, that's what it says to do, right? 4/3 times 2x. Now, what can you do to help yourself out with this? Well, you probably remember, I can put that 2x over 1. That'll make it more obvious what you're doing, because remember with multiplication of fractions, you multiply the numerators together, and you multiply the denominators together. So it's helpful to write the 2x over 1 so you can clearly see what the numerators are and what the denominators are. That's going to give you 8x over 3. There's nothing wrong with this answer, but often what they like to do in these problems, and it makes sense, is they're going to take that 8/3 and bring it out front so you can see the actual numerical coefficient of your variable, because it's the numerical coefficient that will combine with some other coefficient down the road, so they usually bring that out front. So that first chunk is going to have an 8/3 x. Let me get my 8 a little better there. 8/3 x. All right. Then we're going to have a subtraction sign. And then what? Then you got the 4/3 times 3, or 3 over 1. And there's a couple ways you can do this. If you want to do it just like we did the previous one right above it here, you'd write that as 12 over 3, because 4 times 3 is 12, of course, and then that reduces to 4. Or you may recall the option that you have of canceling. That is, you can cancel out these 3 here, and that'll give you a 4 over 1 when you do that, which of course is 4 as before. The canceling here really doesn't save you much time, but there are definitely problems where that canceling idea can be a big help. So you might want to keep that in the back of your mind as you go through some of these problems to make certain calculations a little bit easier for yourself. At any rate, you're going to have a 4 there. And then we move on to the second piece. Let me get rid of this stuff here so I don't need it anymore. Move on to the second chunk here. And what's going to happen here? Well, we have to distribute this minus sign through. You can't just ignore that. It's not a plus sign. It's a plus sign. I can just remove the parentheses. But because it's a subtraction sign, essentially what's going on there is we are distributing a -1 through, aren't we? You can think of that as a -1 there if you want. So I got to grab that entire chunk and distribute through. Just multiply the two pieces by -1. That's not too hard to do, really. All right. So all that really does is change the signs, doesn't it? So I'm going to have a minus 1/2 x, and then a plus, because -1 times -1/2 is plus 1/2 there. There you go. Not too difficult to do, but again, you want to make sure to strip the negative sign through. If you forget to do that, well, then that's going to foul things up. So you got to be on top of this stuff constantly. As you go through the homework and you find once in a while you can't seem to get the right answer, one of the first places to check is negative sign issues. Negative signs are like speed bumps. You want to slow down, otherwise, I don't know, you might break your car driving too fast over. You'll wreck the problem because they're very easy to foul up if you're not nice and slow about it. All right, keep working this. Let's bring the like terms next to each other, the x pieces next to each other, so we can see what we have there. All right. And then we got the -4 plus 1/2. Those are like terms. And let's take each of these in turn. So basically what we have here are, let's say, some apples. These would be the apple pieces, we'll say. And then we got some oranges over here, don't we? Here are some oranges. So apples and some oranges. The apples get combined, the oranges get combined, and then we'll be done with the problem. All right, so let's talk about these apple pieces. In fact, let me do that in red just to emphasize that they're apples there. So what we're going to do here, I'm going to take an 8/3 x minus a 1/2 x. This is not too hard to do. The basic idea, of course, is you've got to get a common denominator. By the way, if you want to make life easier for yourself, what you can do temporarily is remove the variable from the mix. You really don't have to have it in there, because it's all the work, the combining, if you will, is with the numerical coefficients. The variable just comes along for the ride anyhow. It's not really essential. So if it's bugging you at all, if it's causing you to have trouble or just not get the right answer for whatever reason, you can temporarily get rid of it and just work the numerical coefficients. That might be easier to focus your attention on what you need to do. So I've got to get a common denominator here, which is going to be 6, right? Smallest number that 3 and 2 go into is 6. There's your common denominator. And you remember how to play the game. 3 goes into 6 twice. 2 times 8 on top is 16. On the second piece, 2 goes into 6 3 times. 3 times 1 is 3. And then 16 minus 3 is 13. 13/6. And so that would mean this over here would be 13/6x. All right, so that's what goes in this first part here, 13/6x. All right. Now what? Well, let's do the second piece, the orange piece. Let me get rid of all this junk here, because this is limiting our workspace. All right. What about the -4 plus 1/2? How is that dealt with? Well, it's not too bad. That's what we have. -4 plus 1/2. There's no variable to worry about here. One thing I might recommend is writing the -4 over 1, just so you can see, okay, what my two denominators are. Common denominator, of course, is going to be a 2, so that's going to be something like over 2 plus something over 2. And what does the -4 turn into? Well, 1 goes into 2. 2 times -4 on top is -8. The 1/2, I don't have to worry about that. It just stays the same. And what does that give us? -8 plus 1 is going to be a -7 on top. Now let me put that over here. -7 over 2. Now as you piece this together here, at the very end, what you want to realize is these two chunks, the apple chunk and the orange chunk, they're really being added together. It's as though I have this first chunk, this guy right here, plus the second chunk. So in effect, there should be a plus sign in there. Let me get a color to put a plus sign. Let's put a little green plus sign. Oh, good. There's my plus sign in between the two. Like that. So that's what I really have going on there. Now, how are they going to write that answer in the end? Well, they're probably not going to do plus -7. In fact, let me show you a quick example of off to the side here that will probably be even more obvious for you to see. Suppose I had something like this. X plus, what's a lousy X? Put a better X than that. There we go. X plus -4. How might I rewrite that so it's easier to look at? It's cleaner. You know, instead of adding the -4, I was going to subtract off 4 because that's the definition of subtraction, isn't it? Adding the opposite is what subtraction is all about. Let's do that here, and that's how they're going to write the final answer. They're going to write this as 13.6x, and instead of plus -7, they're just going to do minus 7/2. There you go. That's the way they'll write the answer. I suspect most of you already know all this, right? You're familiar with this, but a few of you might have been a while, right? So there's some fine points here, and I just want to bring those out as I can from time to time to help you along, to make sure that you're aware of these issues, and to realize really they're not too difficult to deal with. It's just knowing how to handle them in a nice way, efficient way, makes your life a little bit easier as you grind through these different types of problems you'll be seeing in that first assignment.